Welcome back to the video. In this video, we'll be solving a question from thermodynamics. A portable electric heater with a power of 280 watts is used to boil water for a hot drink. The heater is placed into a cup of water. There is 165 grams of water in the cup. The initial temperature of the water is 12.5 degrees Celsius. Assume all energy from the heater is transferred to the water. The heater is used in London, where the boiling point of water is 100 degrees Celsius. So we have to show that the time taken for the water to go from 12.5 degrees Celsius to 100 degrees Celsius is 220 seconds. So first we need to find out how much work we have to do to increase the temperature from 12.5 degrees Celsius to 100 degrees Celsius. Right? How much energy do we have to put in to water to increase its temperature from 12.5 to 100 degrees Celsius? So for the energy, so we can use the formula E is equals to mc, change in temperature. Now you may notice that the specific heat capacity of water is in Kelvin, but the temperature we have are in Celsius. So do we have to convert these temperatures into Celsius when putting the change in temperature? Well, if you do convert these into, if you convert these from Celsius to Kelvin, and then you find the change, you will get the same answer, right? So if you do it with Celsius or Kelvin, you will end up with the same answer. So don't change it. Just find the change in Celsius itself, okay? Anyways, so we can put the mass, that's the total mass that's present in the cup, and that's the mass of water, minus 3 times 4190 times 100 minus 12.5. That's going to give me 60,493 joules. Now we know the power of the heater is equals to work done divided by time. The amount of energy we need is this much, and the power we have is 280, and the amount of energy we need is 60,493. And we have to find time t. Then t will be equals to 60,000, I think you guys can do that math, and then let me just find that. Time t is 216 seconds, which is approximately 220 seconds. Alright. The same heater is used in La Paz, the world's highest capital city, where the boiling point of water is 87.7 degrees Celsius. The mass and initial temperature of water are the same as in A, and the heater is used for the same time. Calculate the mass of water converted to water vapor as the water boils. So what's going to happen here, as we studied, is we're going to give energy to the water, and the temperature of the water will increase. So the average kinetic energy of water will increase, and the molecules will vibrate more and more. Then we will supply more energy. Okay, we'll supply more energy, and what's going to happen is this energy now will be used to break the intermolecular forces. Okay, so our average kinetic energy will not increase, so the temperature will be constant throughout this period. Now in La Paz, what happens is at 87.5 degrees Celsius the water will boil, okay? And in London it will boil at 100 degrees Celsius, okay? But bear in mind, in both cases, right? So let's consider the La Paz case, okay? First, I will have to supply energy, okay? So I have to supply energy to increase the temperature from 12.5 degrees Celsius to 87.5 degrees Celsius. After that, I have to give it energy to break the intermolecular forces. And that will be equal to the total energy that will be required by the heater. Make sense? So this is that formula. Now I want us to look here. Okay. By the way, you can also say that the energy to break the IMF is also to change the state. This is the energy to change the state. Okay. Anyway, so the formula here works like this. You have M, C, change in temperature, plus M, which is the mass of water that has converted into water vapor, which is what we need to find. So this is what we need to find. L, which is the latent heat of vaporization of water, is equals to P times change in T, which will give me the total work done by the heater. So I know the power is 280. Okay, I know that from before. I think it's going to be, 280. And it tells me in the question the heater is used for the same time. So I can say that the time is going to be 216 seconds. So I can use 165 times 10 to the power of minus 3 times 4190 times 87, I think 87.7 minus 12.5. I think that's 12.5, yep. Plus M, and then L is 2.29 times 10 to the power of 6 is equals to power 280 times 216. The final answer will be 3.1, let me check my calculator, 3.17, times 10 to the power of minus 3 kg. Okay, so that's the final answer.